So to do this, what equation would you use?
I think you would still use a Pythagorean theorem, would you? Because
Um,
what would you do? Well, okay, if you're 500 feet away,
mhm.
so that obviously puts. Wait, can I like draw on this?
Yeah.
Okay, you're 500 feet away. You're right there, and this is where they took off from. That's 500. And they're going straight up. But oh, crud nuggets. Yeah. Oh, shit. Yeah. Okay. You don't have this. You only have the derivative.
I did that. I'm trying to point you in the direction of something.
Yeah.
Is that Pythagorean theorem anywhere?
No, that is not. So yeah.
The Pythagorean theorem.
Yeah. You have to use what is it? Sine, cosine, and tangent. Sine, opposite, hypotenuse, tangent.
Let's say that we're going to fire on the vessel when it's 1,000 feet in the sky.
Okay. All right.
Now which trig function would you use?
Okay, so since you're trying to find what is it? You're trying to find this angle, right?
The rate of change of the angle.
The rate of change of the angle. What the heck?
Rate of change just means d theta dt, and you can get a d theta dt if you derive it. The question is, what am I deriving?
Mm-hmm.
So if you look, I know the opposite leg, I know the adjacent leg, and I'm looking for an angle. So
that's tangent for that.
Tangent, good. And what you can do at that point is just plug in the known information. Okay. Does anything remain constant? Well, the rocket turret's not moving.
Yeah.
And the vessel is going straight up, right?
So, yeah.
So which one of those is not changing? Is it theta, y, or x?
Which one is y and x?
I mean, the y-axis, x-axis.
Oh, right, x, y. Then the x-axis shouldn't change.
Good. So what we can do is we can plug in the 500 for here, multiply it on this side, and now you have a much easier equation to deal with when you're deriving implicitly. Okay. So just for closure's sakes, I'll finish this one off for you, and then I'll try to squeeze in one more topic before we I have to help Brandon here at 1:30. So if I'm deriving this implicitly, what is this derivative of tangent?
If you're deriving it implicitly, coordinates. Derivative of tangent should be tangent secant.
Okay, that's a big problem this far into derivatives that you don't know your derivatives.
Oh wait, no, not tangent secant. No, that's the derivative of secant. Yeah.
Okay. Make some note cards if you want to look in that drawer to the right of the desk, not the actual desk drawer. There are note cards in there with the derivatives. Making them actually helps you memorize them. So my advice to you is to make them. There's some empty note cards in the drawer that are in the desk. If you want to grab some of those and make some note cards on your own, but that's whatever you want to do. Either way, it's fine. So now at this point, we need the theta. So how would we find the theta?
That's when coordinates.
Actually, I'm going to change this 1,000 feet to 500 feet.
500.
The reason I'm doing that is because there is a triangle that has, or one of our known angles has a tangent of 1, right?
Yeah.
Which angle is that?
Wait, say that again.
If I have tangent theta equals
500 over 500.
Okay, that'll give you 1, right?
Yeah.
What is theta? What angle has a tangent of 1?
Oh, that's that should be pi over 4, shouldn't it?
It should be.
Yeah.
All right. So then we can plug in pi over 4 there. Secant's 1 over cosine. Cosine is 1 over root 2 or root 2 over 2 if you were to rationalize it. But I'm going to leave it in 1 over root 2 form because when I do 1 over that, that's what cosine is, right? Or secant. I flip it and I multiply and I get a root 2. And then 500 times root 2 squared gives me an actual 2 there. We're looking for d theta dt. And what is dy dt?
That's your rate of changes. So these leaving at 300 feet per second, so that would be dy. And your x isn't changing.
That's why we plugged it in earlier.
Yeah. So you just have dy over dt. Yeah. Okay.
So when you divide and solve, and you're going to get what d theta dt is.
Yeah. And that would be, well, square root 2 squared is going to be 2. So 300 over 1,000. So what, 3/10? Yeah.
And because it's angled, we would put radians per second because the feet cancel.
Right.
So, bam. Any questions on that?
No. I think I got it.
All right. So you've got enough to practice.